What's up, 8th grade? Mr. Agnos here, and this is slope part 2. In the previous video, we looked at graphs. And when we had a graph of a line, using the rise and the run, we could calculate the slope of a line by creating what we call a slope triangle. And if you remember again from that last video, we would draw an arrow going up and an arrow going over, and it actually creates a triangle with that line. And by writing a fraction with the rise over the run, we were able to calculate the slope of a line. But what happens if we don't have the actual line in front of us? What happens if they just give us 2 coordinates or 2 points that are on that line? It turns out we can still mathematically figure out what the slope of that line would be. So let's take a look. All right, excuse me. This is the second problem that we looked at in the previous video. And again, just to remind you of what a slope triangle is, we would start at the line that's on the furthest to the left. And in this case, I would go down, and then I would go to the right. And we would calculate, hey, how much did I go down? And we'd have that number here, and that number was our rise. And then how much did we go to the right? And that number was our run, and we'd write a fraction. Okay, but I want you to imagine for a second that what if they just gave us the coordinates of these 2 points, of this point right here and this point right here? So the coordinates of this point, let's see, I have to go, remember we always write a coordinate pair as x comma y. And since I'm going to the left 1, 2, 3, then this would be the point -3 for the x value and +7 for the y value. So this is the point -3, 7. And then this is the point, let's see, if I start at the origin, I go 1, 2, 3. So I had to go 3 to the right and 1, 2, 3, 4, 5 down. So what if they just gave me these 2 coordinates? What if they said, hey, here's the points -3, 7 and 3, 5. What is the slope of the line that passes through these 2 points? Well, it turns out that we can mathematically calculate what the length of these 2 arrows would be by finding the difference in the y values, that would be my rise, and the difference in the x values, that would be my run. So we have a little formula for that, and you're going to want to write this down, and you will memorize this eventually. But what the formula says is the slope is equal to, right? Remember this, our variable m means slope. And this time, again, I want you, I'm doing this example with the graph here, but in a second we're going to do it without the graph. We need to figure out what this number is. So what I need to do is I need to subtract the x values. Right? Oh, I'm sorry. That should be a -5. That's a big boo-boo right there. That should be a -5. If I subtract the x values, it'll tell me the distance between them. And if I subtract the x values, it'll tell me the distance between them, which is essentially the length of those 2 arrows. So the way we write that mathematically is we're going to say y sub 2 minus y sub 1. I'm going to get to these little 2's and 1's here in a second. Divided by x sub 2 minus x sub 1. Okay, these little numbers are called subscript, and I think this is probably the first time you've ever seen them. They're not exponents. Okay, exponents go in the upper corner, right? Like up here. What these are is just a way of naming the different variables. Because I have 2 x's and 2 y's, I need a way to differentiate between, hey, which y coordinate am I talking about? So that's all this does. It names each y coordinate so we know which one we're talking about. Okay, so the first thing you do with a problem like this, when you're given 2 coordinates, is you're going to label your points using the subscript. So this is my first x coordinate, so I'm going to label it x sub 1. This is my first y coordinate, so I'm going to label it y sub 1. This is also an x coordinate, but it's my second x coordinate, so I'm going to label it x sub 2. And this is my second y coordinate, so I'm going to label it y sub 2. And then all I have to do is plug these numbers in the correct spot in my equation over here. All right, so the first thing I need to do is I need to figure out, hey, which one is y sub 2? Well, y sub 2 is negative 5. So I'm going to say negative 5, that's y sub 2, minus, right, there's my minus sign, y sub 1. So there's y sub 2, and I'm going to subtract y sub 1. So negative 5 minus 7. What this number is going to tell me is the length of this blue arrow. It's going to tell me how long this blue arrow is, mathematically. And then I need to do the same thing with my x-coordinates. I need to find x sub 2. X sub 2 is this number right here. 3 minus, it's always a minus sign, x sub 1, which is negative 3. Okay, I'm subtracting a negative 3. So it should look like this. All right, then I just go ahead and subtract. Negative 5 minus 7. I'm getting more negative. So that's negative 12 divided by 3 minus a negative 3. Remember, when I subtract a negative, it's the same as adding. So that becomes 6. Negative 12 divided by 6 is negative 2. And if you remember from the previous video, this is exactly the same answer we got by making the slope triangle. If you count these boxes right here, you'll get, there's 12 boxes and we went down. So that would be a negative 12. And if you count these boxes right here, you'll see that there's 6 boxes. So we got those exact numbers right here. It's just this time we had to do it mathematically. All right, so for this one, I gave you the graph. Now let's look at a problem where you don't have the graph, and we have to do it all from scratch using the math. All right, the first thing you should always do with this type of problem, especially because this is your first time, is we're going to write with the slope formula. Slope is equal to, well, remember, slope is equal to, from the first video, it's equal to the rise over the run, except this time we don't have a graph, right? I can't just count boxes to figure out what these are. So I need to do the math. And the math in this situation is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So let's look at our coordinates, plug them in, and figure out the slope of the line that would go through these points if we had the graph in front of us. So I'm going to start by rewriting them. I have negative 1, and 3, 7. All right, step 1, label the coordinates. This is my first x coordinate, so it's x sub 1. That's ugly. So it's x sub 1. This is my first y coordinate, so it is y sub 1. This is my second x coordinate, so it's x sub 2. And this is my second y coordinate, so it is y sub 2. Now I just take these numbers like they're puzzle pieces and I plug them into the correct spots in my equation. The first thing I need to do is find y sub 2. Here's y sub 2 right here, so I do 7. I always have a minus sign. And then I need to find y sub 1, which is right here. So 7 minus a negative 1. So this will tell me the length of my blue arrow. All right, going to the bottom, I need to find x sub 2. X sub 2 is right here. So that's 3 minus x sub 1 is negative 1. And then now I need to calculate what these numbers are. All right, remember from what I just told you, when we subtract a negative, it is the same as adding. So 7 minus a negative 1 is the same as 7 plus 1, which is 8. If I subtract a negative, it's the same as adding. So 3 plus 1 is 4. 8 divided by 4 equals 2. So if I were to actually graph this line right here, it would look something like this. That would be roughly the angle of it, and it would have a slope of 2. Got it. Okay, This definitely takes a lot of practice. You're going to struggle. A lot of students are going to make mistakes. They're going to set it up correctly, but then doing all these types of calculations here, adding positive and negatives, they're going to make mistakes. Another thing I didn't mention in the previous video is you're not always going to get a whole number answer. You might get a slope of 4/5, or you might get a slope of 3/2. That is perfectly okay. All right, it just means go up 3/2, up 3/2. This one means go up 4/5, and so on. Excuse me. So you may get a proper fraction, you may get an improper fraction, or you may get a whole number. Those are all possibilities. You're never going to write a slope as a mixed number. So if you get an improper fraction like this, you leave it as an improper fraction, but you do have to make sure it is simplified. Okay, I got 2 videos for you, and I've covered a lot of stuff, and this is really meaty stuff. This is we're going to spend a lot of time on this. So remember, this is the first coat of paint. It's not going to go perfect the first time through. You can watch these videos as many times as you like. Definitely, you're going to have to be doing work on paper next to you. You're going to have to write down rise over run. You're going to have to write down the slope equation. Ask questions in class. We're probably going to spend a couple of weeks on this, because what the slope is really measuring is how much something is changing over time, right? And I keep going back to my touchdown example when we were talking about proportional relationships. That line would have a slope of 6, right? I go up 6 points for every 1 touchdown I score. Up 6/1, up 6/1, and I keep going in that pattern. So that's where we're headed, is that slope is really a way of telling us, hey, how is whatever we're measuring changing over time? Okay, please ask lots of questions in class. This is going to take some practice. Again, normally in the classroom, we'd be doing this 5 days in a row. Here we have 2 days in a week, so we'll probably go a couple of weeks on this. There's lots of special circumstances kind of situations, and we'll examine those as they come up. All right, I'll see you guys in class.